G'day guys, we've got an anti-differentiation question here today where we've got a curve with gradient function of y dash equals 12x take 12 and it cuts the x-axis at 2 points, 3, 0 and k 0. We have to find the value of k. Okay, so this derivative function or gradient function is a linear, so we can assume that the function that it came from will be quadratic. So if we just quickly stop for a second and work out what we're going to try and do. We've got an original function that has a shape like thus. So we've got two x-intercepts. One's there. Oh, I don't know if it's there exactly, but we've got two x-intercepts and one of them is 3, 0. And we've been asked to find this one here. So this one is what we're looking for. So I hope you guys remember, if we have a function that is, this is ax to the power of n, its derivative is going, or y dash, is going to be equal to, we times the n down, so we have n a x to the power of n take 1. Cool. So basically what we have to do here is we have to work backwards with antidifferentiation. So what we're going to do, let's just write out our function that we have. We have y dash equals 12x minus 12. Now, let's figure out what this means. So what we have to do, we are here and we have to go backwards. So what we're going to do first is we're going to, hopefully you guys will realize that the power of x here is 1. And also, when we have no x, that's like saying x to the power of 0, because that's just equal to 1. So, knowing this, what we're going to do is our function is going to be equal to, well, we increase the power by 1, so to work backwards, rather than taking on, we add 1. So we're going to have x to the power of 2, and rather than multiplying by the power, we divide by this new power. So we're going to have 12 divided by 2 minus. Now we take this up, we add 1 to the power of this one, and we have just x to the power of 1. And then we divide it by this new power by 1. And most importantly, guys, well, not most importantly, but importantly, guys, we have to add a c term to this. Cool. So from here, we can just simplify it. So we're going to have y dash, or y, sorry, 12 over 2 is 6, x squared, subtract 12x plus c. Now, in order to work out this x-intercept, we're going to need to know what our c term is, because our c is our y-intercept. So the way we do that is we've been given this piece of information here. So we can use this piece of information to find c by subbing in x equals 3 and y equals 0 into our function. So we're going to sub in those numbers. So 0 is equal to 6 times 3 squared minus 12 times 3 plus c. Cool. And this is equal to 6 times 9 is 54 minus 12 3s are 36 plus c. So from here we're left with c equals negative 18. Great. So what we can do from there is now we have our function y equals 6x squared, take 12x, take 18. Now, to find the x-intercepts, we can either use the quadratic formula or we can try and factorize this. So I was going to try and factorize it. So let's have a go. So we'll first factorize it by 6. Cool. And from here, we need something that adds together to give negative 2, multiplies together to give negative 3, and I think we've got that one in the bag as well. So it's going to be x take 3, x plus 1. Cool. Okay, so the other x-intercept, this has to be equal to 0. So using the null factor law, so we can, by the null factor law, the x-intercepts have to be x has to equal 3, because that bit there has to equal 0, or this bit here has to equal 0. So x equals 3 or x equals -1. So we can write, finally, we can write, hence, k, the other x-intercept is equal to -1. Cool. So guys, I hope, I've gone through this relatively fast, but first of all, we need to understand that antidifferentiation is simply just going backwards when you're doing the derivative. So rather than multiplying the coefficient by the power, you divide the coefficient by the new power. And rather than taking 1 from the power, you add 1 to the power. So 1 would go to 2, 0 would go to 1, etc., etc., etc. So I would just practice going backwards in these and making sure that you might think that this is a bit tedious, this step here that I did, but it just ensures we don't make any mistakes. But, again, guys, just keep practicing. This is a moderate, I would say simple to moderate sort of anti-differentiation question. You will get harder ones, but this leads on to what's called integration afterwards. So I hope this video helped, guys. If it did, definitely give me a thumbs up. Subscribe to my channel. I put out new videos almost every single day. But until next time, guys, enjoy your maths.